like we can draw plots in Cartesian coordinates by knowing a relationship between x and y and then drawing all the points that satisfy that relationship. We can do the same in polar coordinates. We just need some relationship between r and theta, and we think about all the points that will satisfy that relationship. Okay, so if our relationship is that r is just equal to a constant, well, this has no relation on theta, so r is going to be the same for all values of theta. So the graph, we draw our half line. Okay, so this is the origin point, and then as we go round, that's an increase in degrees. Okay, so 0 degrees here, we go around anti-clockwise 2 pi, anti-clockwise again 4 pi, and we keep going. But for all values of theta, and this is a terribly drawn circle, we just get a circle with constant radius. So let's say this is equal to lambda. Okay, and hopefully that's intuitive. If we know something's a constant distance away from a point, no matter what the angle is, we have to get a circle. Okay. So one more example. If we look at an equation of the form r is equal to a times theta, we'll take where a is greater than 0. You can equally do this for negative a. I just want to specify this case for now. So we need to think, what does this mean? Well, first of all, when theta is equal to 0, r is equal to 0, so we start at this origin point here, and then as theta increases, r increases. Okay, so r is proportional to theta, so as we're going round, okay, with varying values of theta, the distance from the origin gets greater, so we get this spiral like shape. Okay, and that keeps going, because it's not like here the value at 2 pi is the same as 4 pi or 6 pi or 8 pi. Here when we have extra multiple pi, we just get wider and wider and wider and wider and wider. Okay, so this isn't a great drawing. If we're going to draw this, just we would just perhaps draw this, because we can only see up to 2 pi. It's hard to tell when drawing multiple graphs whether like this is the point at 2 pi, whether this, okay, like it's not very clear. But what you can do, and I encourage you to do, is look up sort of time evolution graphs. So you can these will allow you to like cycle through values of pi, and then it will draw as the graph grows, which makes a bit more sense visually to look at. But yeah, we tend to just plot in the region of on some specified region theta that you'll be given. Yeah, so hopefully you're comfortable with these ideas of plots, and next we'll move on to integration, finding areas in polar coordinates, and also looking at maybe a couple more complicated examples of plots, but nothing too bad. Just want you to remember the ideas here, that just like if you have y as some function of x, you might plot in some key values of x to find values of y, and then to figure out the shape from that. You can do similar things with r and theta, okay, given a relationship. So that's it for this video. Thank you very much for watching. I hope to see you